Hello, my name is Nathan Hall, and this presentation is on behalf of the MetaArchive. I'm working with Nathan Tallman, Technical Facilitator, and Alex Kinnaman, Secretary of the Steering Committee and Co-Chair of the Outreach Committee. MetaArchive is a community-owned, community-governed social digital preservation network founded in 2004. Along with the Library Publishing Coalition, the Software Preservation Network, and the Bit Curator Consortium, MetaArchive is facilitated and supported by Educopia. Based on LOCK's decentralized digital preservation infrastructure, each member can deposit content and have it replicated and managed at other nodes or servers at other member institutions. So to get us started, here's a rhetorical question. In a market with cheap cloud storage, is LOCK still a viable, efficient, and affordable option? It requires membership dues, hardware, and systems administration time at member-sustaining institutions. Aren't there easier ways to preserve content? So a number of external and internal factors signaled that MetaArchive was entering a transitional period that required a change management process. So in 2020, the cooperative engaged members in a change management exercise led by Educopia Executive Director, Catherine Skinner. And from there, we align with the conference themes around emergent institutional and social cultural barriers, risks and opportunities inherent in preserving digitality, and balancing innovation with long-term planning and maintenance. And as a result, the cooperative made, through that change management process, the cooperative made proactive adjustments to its community model, its technical interoperability, and the ways it engages with the broader distributed digital preservation field in an intentional effort to remain relevant, useful, and impactful. A major area of transition has been in technology exploration with the goal of exploring and testing new technologies for distributed digital preservation. Internal motivations for technological explorations included network and server infrastructure. It included how network and server infrastructures are quickly moving out of the library and off campus. This has made it much harder for members to host caches. This makes the caches harder to maintain. Upgrades, et cetera, have to go through more levels of bureaucracy. And there's been a decrease in the number of caches. And this has put the LOCK's model to the test as it relies on members having administrative control over certain aspects of their infrastructure. MetaArchive also employs several technical consultants hired for specific tasks, but they end up working on more than their time and bandwidth allow. Additionally, there's limited time and bandwidth for member participants. There are a lot more organizations focused on digital preservation and digital curation than there were when MetaArchive started. Furthermore, changes in leadership at member institutions and changes in digital preservation staffing have occurred. Library deans who bought in on MetaArchive are no longer at their original institutions. The active participants, or rather the staff at MetaArchive institutions charged with digital preservation activities, were different people than when MetaArchive started. So they're not necessarily as invested in the culture and activities of MetaArchive. Staff at member institutions have been having a harder time finding the time to participate in MetaArchive. An active LOCK's network can be prohibitively expensive to operate in the cloud infrastructure environment because caches are constantly communicating, causing lots of data input and output. MetaArchive is investing in other models for distributed digital preservation using software-defined storage. We are also testing LOCK's 2.0 to see how it might be implemented with our current infrastructure. To support these explorations, the MetaArchive community and our technical consultants are improving the documentation of our current infrastructure and performing a prioritization of criteria for digital preservation storage. Finally, as an organization, MetaArchive has been reviewing our staffing model to adapt to these new changes. Our first goal is exploring software-defined storage. Software-defined storage is an abstraction that separates the underlying storage media and systems hardware from storage administration and users. It includes storage media, as in the hard disk drives, the solid-state drives, the optical media, and tape that can be easily refreshed or replaced as needed. It includes storage hardware that can easily be expanded from one rack to hundreds and even span multiple data centers. Storage can be provided through multiple protocols for maximum flexibility. And file storage includes network storage, file systems and addresses, file systems addressed with file paths, and block storage, virtual hard disks for virtual servers addressed with logical block addressing. and object storage, or discrete storage packages addressed with URLs. All this removes dependencies for specific system architectures and proprietary hardware. Software-defined storage features scalability in storage, flexibility on storage types, web-based user interfaces for self-service, and automation to set policies and actions. SDS also provides some key digital preservation priorities, including data integrity checks, replication of content, transparent resources and costs, and hardware diversity. Software-defined storage can be used as the core of a distributed digital preservation network, but it's not a complete solution. Additional infrastructure would include a dashboard, ingest service, and recovery service. This is a very basic model focusing on bit-level preservation that scales. Additional services could be incorporated for more complete preservation, such as fixity and normalization and conversion. And thank you to Wendy Adams at Penn State for drawing this diagram that we've adapted for this presentation. MetaArchive began exploring Stanford's approach to software-defined storage, which stemmed from their work on software-defined networking. We met with several firms, and we are currently working on an MOU to proceed with a software development firm that specializes in software-defined storage. The potential network would be built on software-defined storage with object file block-level storage with protections built in, including Ceph for object storage, which is also open source, and Apache NiFi, which is a no-code workflow tool that a non-expert could use to drag and drop into a workflow. This removes the dependency on the availability of developer time. MetaArchive is taking a three-phased approach to investing in software-defined storage for MetaArchive. Our first step is underway as we gather requirements from the membership. We have created functional requirements based on detailed survey responses from the membership, on criteria members believe are required for building a digital preservation system. Simultaneously, we are actively participating in facilitated meetings with a software development firm to understand what is possible. The goal of this initial step is to apply this software-defined storage project to an entire digital preservation system and not limiting to just a storage service. If we all approve of moving forward together, phase 2 will be building a prototype based on our criteria and using Ceph and NiFi to create a proof of concept for testing. Phase 3 will then be fine-tuning the details. We will determine what software is hosted by members versus what is hosted centrally at MetaArchive, and whether the firm is responsible for performing any operations, and also the division of labor between the firm and MetaArchive. We will also develop a sustainable model for cost and labor for MetaArchive in this arrangement to ensure its long-term viability, and we will continue to ensure administrative diversity in how we manage nodes and content. While we explore software-defined storage for MetaArchive, we're also evaluating our current infrastructure on LOX 1.0. MetaArchive has experienced challenges over the deploying, maintaining, and interoperating with the current architecture. It's important to note that the weaknesses and challenges are mostly specific to LOX at MetaArchive rather than general LOX issues, the exception being content management. The evaluation resulted in 3 major points. The strengths of LOX 1.0 for MetaArchive are in viability and cost effectiveness, and the continued uptake of LOX in the digital preservation field. Also resulted in the clear demonstrated performance as we have historically used the system. In contrast, the weaknesses and challenges of LOX 1.0 and MetaArchive included consistent maintenance and uptime problems. Finally, the issue of scalability and sustainability that scale over time, and content management issues, which are not unique to MetaArchive. There are also several opportunities to continue in the use of LOX 1.0, including additional staging server developments built on our current infrastructure, ingest and reporting tool improvements, and next generation solution reviews. While evaluating LOX 1.0, we are also evaluating LOX 2.0 to see what happens as it interacts with LOX 1.0 by adding it directly to the MetaArchive test network. The initial results showed implications for plugin development, which is how we ingest content, and implications for staging. The staging implications in particular are interesting because the LOX 2.0 new APIs may give us new ways to ingest content into the network. The other prominent results were to figure out where and how our networking monitoring tools, which are homegrown, and network management tools will need to be rebuilt such as where we will need to switch to the new LOX 2.0 APIs. The technical committee has been working to create a centralized staging and ingest server, which directly aligns with our experiments with LOX 2.0. We are hoping to support the exploration of a way to ease LOX use with other private LOX networks, like ADPNet and SafeVault. This also ties in with the digital preservation storage criteria information we are gathering from our members. With all these new and potential changes, the technical committee and our technical consultant, Nathan Tallman, have been improving and updating MetaArchive documentation. The most notable change are the updates to the MetaArchive technical specifications, which outline the current recommendations and requirements for administering a preservation cache for the MetaArchive Cooperative, including staffing and hardware. And the goal is to make all of our documentation as open and transparent as possible to members and potential members. On the back end, we are also consolidating and updating our wiki, which is where most of our internal technical documentation and how-to guides exist. Currently, the people doing all of this work is a matrix of technical consultants doing bits and pieces of technical work for Educopia and MetaArchive. This is not a sustainable process, as the technical consultants tend to become overextended, and the work between consultants is not as cohesive as it could be. MetaArchive leadership is working with Educopia and the MetaArchive Technical Committee to evaluate staffing models to fill gaps across Educopia that works efficiently for everyone without overextending our technical consultants. To summarize, the times are changing. We are actively exploring software-defined storage, updating to LOX 2.0, and adapting our documentation and infrastructure to these explorations. MetaArchive has been active since 2004 and survived this far by adapting to new methods, new technologies, new infrastructures, and new people to stay healthy. Change in digital preservation is inevitable, and we are working to ensure that we can collaborate with other organizations to meet the needs of the MetaArchive community while balancing the sustainability of our infrastructure. Thank you for listening. Please feel free to get in touch with myself, our technical consultant, Nathan Tallman, or our outreach co-chair, Alex Kinnaman, with any questions, comments, and feedback. Thank you very much and have a great day.